All right, hello everyone. So this is literally a B costume, as in, well, one, it is a B, and then it's not like an A level costume, more on a B level costume. Not the greatest, but hey, we are the Medina Bees, so I figured I kind of had to do this. And when you see something like this at a resale thrift shop and it's like $2, even though it's a little girl's costume, bows and all, but it still has some stretch. You kind of got to do it. So here we go. We're going to take a look at dividing complex numbers today. All right, so we said we're going to divide some complex numbers. So a little bit more specifically, we could say that we're going to simplify fractions containing complex numbers. And along the way, we're going to have to use complex conjugates to help us simplify some of those fractions that have complex numbers in them. All right, before we do that, we need to remember that I, our imaginary unit, is the square root of -1. Yes, the square root of -1 does not exist, but if it did, we could imagine what it would be equal to. All right, so that's why it's I is equal to the square root of -1. If you took that I was equal to the square root of -1 and you squared both sides, you'd have I squared was equal to the square of the square root of -1. Square and square root cancel each other out, so you'd be left with just a -1. Therefore, I squared is going to be equal to a -1. So keep in mind that our final answers are never going to leave a negative inside a square root. Anytime you have an I squared, you're going to simplify it to a -1. And also, we're never going to be allowed to leave an I in the denominator. All right, so what are we going to do to get that I out of the denominator? All right, we're going to use complex conjugates to help us get the I out of the denominator. So if the complex number is in the form A plus BI, its complex conjugate is then A minus BI. So you keep the numbers the same and you just change the symbol in between them. So a couple other exact examples instead of just generically, algebraically. We have 3 plus 2i, so its complex conjugate would be 3 minus 2i. If we had 5 minus i, its complex conjugate would then be 5 plus i. And if we had just 3i, that's just like 0 plus 3i. So then its complex conjugate would be 0 minus 3i, which could be looked at as just negative 3i. All right, so here we go. We have 4 problems, and then you can go ahead and complete our assignment. So here we go. All right, so here's our first one. We have an I in the denominator, and we could think about this actually as 0 plus 2i. And then again, if that was thought about as a plus bi, then its conjugate is going to be a minus bi. So its conjugate is going to be 0 minus 2i. All right, but we don't want to change the value of the fraction. We just want to change the way that it looks. So we need to make sure that we multiply the top and bottom. All right, the top and bottom by that 0 minus 2i by the conjugate. All right. Well, that 0 minus, it's going to make our life a whole lot easier. We know 0 minus is just the negative 2i anyway. All right, so it would be easier probably to just look at it this way. All right, so let's just go ahead and do that. So we're just then distributing the negative 2i to the whole fraction. All right, so negative 8i, negative 10i squared, and then down low, negative 4i squared. Okay. Remember, our I squareds turn into -1s. Okay. And then we have negative 8i plus 10 over 4. We should simplify this fraction. I strongly suggest doing separate fractions. Negative 8i over 4 plus 10 over 4. It's going to give us a negative 2i plus 5 halves. And we should put our answer in standard form. Standard form always has the real piece first and the imaginary piece second. All right, real piece first and imaginary piece second. I strongly suggest when we simplify our fraction, our big fraction, to change it into two separate fractions, because too often I see students try to do this, and they would just cancel here and say that it's negative 2i plus 10, which is not our answer. All right, which is not our answer because the 10 was also over the 4, so the 10 had to be reduced individually. So please, 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 please don't do that. I think a good way to not make that mistake is to do separate fractions and then reduce individually. All right, so here we go. We have an I in the denominator, so we need the conjugate of the denominator. The conjugate of the denominator, if it was 2 minus 3i, it's going to turn into 2 plus 3i. Again, we don't want to change the value of the fraction, so we're going to need to make sure that we multiply it to the top and bottom. And then we're going to have to FOIL for the numerator and for the denominator. All right, when we FOIL, all right, in the numerator, first gives us 5 times 2, which is 10. Outer, 5 times 3, 15i. Inner, I times 2, 2i. And last becomes 3i squared. When we FOIL down low, 2 times 2 is 4. Outer, 2 plus 3i, 2 times positive 3i becomes 6i. Inner, negative 3i times 2, negative 6i. And then the last, negative 3i times positive 3i, 9i squared. Let's see here. In the numerator, 10 and 17i. That I squared is going to turn into that negative 1. Down low, 4. We have a plus 6i and a negative 6i, zeros out. And then the minus 9i squared, we have the minus 9, and the I squared again turns into a negative 1. All right, where are we at? Becomes 10 plus 17i minus 3 over 4 plus 9. So we're at 7 plus 17i over 13. We can't reduce that, so we can leave it just like that. All right, here we go. Again, we have an I in the denominator, so we'll need to multiply top and bottom by the conjugate of the denominator. If the denominator is 3 plus 5i, its conjugate 3 minus 5i. All right, and to the top and bottom again. So we have to FOIL for the numerator, FOIL for the denominator. Numerator, first 2 times 3 is 6. Outer, 2 times negative 5i, negative 10i. Inner, negative 8i times 3, negative 24i. Last, negative times negative is positive. 8 times 5 is 40. I squared. Down low, 3 times 3 is 9. 3 times negative 5i, negative 15i. Inner, 5i times 3i, plus 15i. Last, 5i times negative 5i, negative 25i squared for FOILing. All right, let's see here. Simplifying, numerator 6 minus 34i. We have that 40, but it had an I squared attached to it. Our I squareds we know again are negative 1s. We have our 9. Those zero out. And then again, it had an I squared with it. Turns into a negative 1. So we're at 6 minus 34i minus 40 over 9 plus 25. That's what, a negative 34 minus 34i over 34. All right, again, I would suggest separate fractions to simplify. That's going to give us negative 34 over 34 minus 34i over 34. It's going to become then negative 1 minus I. All right, before we multiply the top amount by the conjugate with this one, I feel like we should do some simplifying in the numerator. We do not just distribute that exponent because the operation inside the parentheses is addition, so we need to expand so that we can then FOIL. Alright, so in the numerator, we have 4 plus 2i plus 2i plus I squared. Still not done with that numerator. Negative 3i minus 4i, or I squared, 1 plus I. I squared. So negative 3i plus 4 over 1 plus I. It's not in standard form in the numerator, but it's not our final answer, so that's all right for right now. So now we can go ahead and multiply by the conjugate of the denominator, 1 minus I. So we'll FOIL again. What's that give us? Negative 3i. Outer plus 3i squared, inner 4, last minus 4i, down low 1 minus I plus I minus I squared. Numerator 4 minus 7i plus 3 times negative 1. And then down low, 1 minus I and plus I, 0 out. And then it was minus, but we have an I squared. So where are we at? 4 minus 3 minus 7i over 1 plus 1. So 1 minus 7i over 2. All right, so that's it. Hopefully it wasn't that difficult. It is stuff that we have seen already before. Using conjugates, we will use again in our next lesson. So have a good day. And I feel like I kind of have to do like superintendent, our old superintendent, Mr. Knight used to do, and kind of leave us with one more buzz.